Hi friends, welcome to our channel. Let's have a look at problem 1438, longest continuous subarray with absolute difference less than or equal to limit. You can compare this problem with problem 1425 and problem 2294. So those two problems are on subsequence. So here we are considering subarray, right? So for this problem, our strategy will be the following. So we're going to use sorted list. So this is to be used to track the min and max within a window. The second ingredient is two-pointer sliding window technique or trick. So basically, we want to bound the longest valid subarray ending at each index. So here, actually, the first thing we need to think of is why can we use two-pointer sliding window method here? So if you have practiced a lot on two-pointer sliding window method, I hope you can think a little bit deeper on this problem. So here, the short answer is monotonicity. So basically, for using two-pointer sliding window method here, we want to find for each R the corresponding longest valid subarray. In other words, we need to find the smallest L. So let's call this relationship as a function, the f r equals L, such that nums starting at L and ending at R is valid. So then, if we increase R to a larger one, corresponding to sliding the window to the left, to the right, then the corresponding f r larger should be greater than or equal to L. In other words, at least L. So this is the necessary monotonicity we need to do this two-pointer sliding window method, because we don't need to start over L again, right? So for this problem, actually, the method we are going to present here is not the best or not the fastest, but it's not. I feel it's very clean and it's very easy to expose to you the whole logic. And another thing to notice is that for this problem, example 2 is a very good example. So here the limit is 5. For example, you can have 10, 1, 2, 4, and 7, 2 if you partition like this. So it's good. But you cannot have 1, 2, 4, 7 because 7 minus 1 is 6, right? Greater than 5. But this will yield length 3. And also you can have like this, 10 and 1. And you stop here and then you have 2, 4, 7, 2. So this way you are going to have 4. And this is also our return. So I think if you notice this one, you could digest the subtle point of this problem. So now let's look at the coding. So coding, if you use sorted list, will be rather straightforward, because in sorted list, within a window, the first element in the container will be the minimum, and the last one will be the maximum. Then as long as the two ends have absolute difference bounded by the limit, then every element sum of difference of two elements within this window will be less than this bound. So for less than or equal to, let's first initialize a result. This result is the counting variable. We are going to return its final state. And then I have a window. I'm going to just use sorted list. So if you want to use it not in a leetcode setting, you need to import this one from sorted containers, right? And then I'm going to introduce this in as so just for convenience of writing. So this in it retrieves this O1 time complexity. So we have a left pointer that is L equals 0. And then we are going to iterate for R in range n. Basically, we want to find for each R the corresponding longest valid subarray ending there, right? So here, because we are considering this one, let's first add nums R. And then we are going to look at the sliding window. So well, L is less than R, and window -1 minus window 0. If it's greater than the limit, then we are going to slide the left pointer to the right. So this corresponds to discard. So nums L. Then L is incremented by 1. So now let's look at the and the condition for this value, either L equals R, we can't implement. It's impossible because for each single element, so we regard the difference with 0. So then this condition will be validated. That is, the largest minus smallest is bounded by the limit. Therefore, so we're going to have update the result, because here the valid subarray is ending at R and beginning at L. So we are going to have the length is R minus L plus 1. And then after this for loop, we're going to return the results variable. That's actually the full code. Let me first run it to make sure it works. Yeah, it passes the 3 test cases. Now let's look at the generic case. Yeah, it passes all the cases. So actually we can do some print, right? So we can print R, and then also we can print L, and also we can print if you like, the R minus L plus 1, the length, right, ending at R. Let's write at this R. So let me print out this. So for the first example, it should be rather straightforward, right? So any at 0, you have 1. Any at 1, you can only have 2 itself. Any at 3, you can have 2 and 4, right? So any at 3, you can have 2, and the length is this. Any at 2, actually, you can also have this 2. And any at 3, you can have L equals 2, you have 4, 7. So the main point is to look at example 2. So let me run again. So for this example, so R equals 0, L equals 0, R equals 1, and L equals 1. R equals 2, we should have L equals 1. R equals 3, we also have L equals 1. And R equals 4, no, you cannot have L equals 1. You have 2, right? So 4 and 2. And when you have 5, you can also have 2. So 5 minus 2 plus 1, that is 4. That's the return for this example. I guess with that said, that's about it for the current video. Let me comment again. So the way I'm presenting here is not the the most efficient one, but it's very clean. So it also demonstrates how to use sorted container. So I guess for this problem, it's better to solve it using a number of other techniques so that you can have a better understanding. With that said, that's it for the current video. Thank you for watching.